Welcome to the Explainer. If you're wrestling with Java, you know there are two big topics you absolutely have to nail: interfaces and exception handling. So today, we're going to break them both down and focus on exactly what you need to pass those assignments and exams.
Okay, let's really hang on to this idea because it's going to make everything else click. The rulebook. That's all about how we write solid, predictable code from the get-go. And the safety net, well, that's our plan for when things get unpredictable, making sure our app doesn't just crash and burn.
So here's our game plan. We've got 5 key areas to hit. We'll kick things off with the rulebook, what interfaces are and how they let us pull off a clever version of multiple inheritance. Then we'll switch gears to the safety net, covering the basics of exception handling, a few advanced tools, and even how to cook up your own custom exceptions.
First up, let's talk about the rules of the game with interfaces. You can really think of this as a non-negotiable contract that your classes have to sign on the dotted line.
So, at its heart, an interface is basically a list of promises. It strictly defines what a class must be able to do, right? It lists out all the methods. But, and this is the important part, it says absolutely nothing about how the class should do them. That job is left entirely up to the class that implements the contract.
And just look at how strict this rulebook is. Any variables you declare are automatically locked in as constants. The methods, they're just empty shells, pure blueprints with no code inside. And that's exactly why you can't create an object directly from an interface. It's not a thing, it's just the plan for a thing.
So you might be asking, why have such a rigid, abstract rulebook? Well, it's because it lets Java solve a huge design puzzle, and it unlocks one of its most powerful features.
Now this is a classic exam question, for sure. Java, by design, doesn't let a class inherit from multiple parent classes. It just gets way too messy. So, if a class can only extend one other class, how do we give it functionality from lots of different places?
And here is the brilliant solution. A class can only have one true parent with the extends keyword. That's its main identity. But it can promise to follow the rules of many different contracts by using implements. So our smart car is, at its core, a vehicle, but it also promises to follow the rules of being drivable and connectable. It gets the best of both worlds.
These are the points you've got to remember for your assignments. Yes, interfaces can inherit from other interfaces, and a single class can both extend a parent and implement a bunch of interfaces. But a heads up on that last point. If you try to implement 2 interfaces that have a variable with the exact same name, your code won't compile. That's a common tripwire.
All right, we've used the rulebook to build our program. But we all know that in the real world, things go wrong. So now, it's time to set up our safety net.
So exception handling is Java's system for dealing with all the problems the compiler can't predict. You know, what happens when a user types letters into a number field, or a file you need is missing? Without a safety net, your program just stops. It crashes. Exception handling is what catches the program and lets it deal with the problem gracefully instead of just failing.
Understanding this family tree is super important. Everything bad that can happen comes from throwable. Now, on one branch, you have error. Think of these as catastrophic system failures, like running out of memory. You generally don't and can't do anything about these. But on the other branch, you have exception. Now this is our world. These are the problems we can anticipate and build a safety net for.
The basic system is a really simple 2-step process. First, you take the risky code, the part you think might fail, and you wrap it in a try block. If something goes wrong inside that block, the normal flow of the program stops dead, and it immediately jumps to a catch block, which is where you've written your plan B for how to handle that exact problem.
And then there's the finally block. You should think of this as the cleanup crew that always shows up. It doesn't matter if the try block worked perfectly or if it failed and a catch block ran. The code inside finally is guaranteed to execute no matter what. This makes it absolutely perfect for things like closing files or database connections so you don't leave a mess.
Okay, let's level up. Now we're going to look at some more advanced tools that give you even more precise control over how you manage and signal errors in your code.
Okay, listen up, because I guarantee this will be on your exam. The difference between throw and throws. Throw is the action. It's the verb. It's you inside a method actively launching an exception like a flare gun. Throws with an S is the declaration. It's the warning label you put on the method signature that tells everyone else, hey, be careful when you call me. I might throw an IO exception, so you better be ready to catch it.
So what happens if a piece of code could fail in a bunch of different ways? Easy! You just chain your catch blocks one after another. The program tries the code, and if an exception happens, it goes down the list of catch blocks until it finds the first one that matches the error. It's like having a series of different-sized nets to catch different kinds of problems.
You can even nest your safety nets inside each other. This is for those really tricky situations. For example, imagine you try to write to a file, and it fails, okay? So you jump to your catch block. Inside that catch block, you try to write an error to a log. But what if the log is also unavailable, and that fails too? A nested try-catch lets you handle these messy, layered failures.
All right, final big topic. What do you do when Java's built-in exceptions, like IO exception, just aren't specific enough for what your program is doing? Well, the great news is you can actually create your very own.
And this is the whole reason you do it, to create errors that speak the language of your application. Instead of some generic I-argument exception, a banking app can throw a much clearer insufficient funds exception. It makes your code so much easier to understand and your error handling way more precise.
And you know what? Making your own custom exception is surprisingly easy. Seriously, it's just 3 steps. 1. Make a new class and end its name with exception. 2. Have that class extend the built-in exception class. And 3. Create a constructor that just takes a message and passes it up to the parent using supero. And that's it. You've just created your own type of error.
And as the course material for this explainer puts it, that's really the bottom line here. All of these concepts, interfaces, try-catch, throw, custom exceptions, they're all about one thing: building software that's more flexible, more robust, and more reliable.
And that really leaves us with the big question to think about. Becoming a great Java developer isn't just about memorizing syntax. It's about gaining the wisdom to know when to enforce the strict rulebook with interfaces and when to prepare for chaos by deploying the safety net of exceptions. Finding that perfect balance, well, that's the key to truly solid code.